Okay, today we are going to be doing some questions related to trace tables. So trace tables are a method of checking through a program's code manually and examining what's being stored inside of each variable and like what's being outputted by the program. So this helps us to check if our program currently works without having to run it. And it helps us to identify any logical errors that might have occurred. Okay, so let's do this question from October-November 2025, paper 23. So a program has been written in pseudocode to input 5 numbers between 1 and 900 inclusive and store the highest number and lowest number entered. So complete this trace table for the algorithm using the following numbers. And then we are given 5 numbers. So these 5 numbers are these 5 numbers inputted by the user. So what we are going to do is that we are going to go through the code line by line from the top to the bottom, and then note down the contents of the variables and any outputs that are produced. And also when doing trace tables, we should not skip ahead in the program unless we specifically have to. So let's do this question now. Okay, so starting from the top, in line 1, the variable lowest is initialized with the value 900. So we're just going to put it into the first row under the variable lowest. And then on line 2, highest is initialized with 1. So we're going to put it here under the highest column. And then now on line 3, we start a for loop. So the for loop will run 5 times, where a counter will be updated starting with 1 and then incremented until it reaches 5. And then during this for loop, all of these lines will be executed. So what I'm going to do is that I'm going to put this 1 into this next row here because I want to show the examiner that this is a new stage in the program. Like this is separate from this. So I'm going to put it in the next row instead of here with these two. And then on line 4, we have to input number, which refers to this. So the first number that's inputted is 563. So I'm going to put it here under number. And then now we're doing an if check. So if number is less than lowest, then do this. Otherwise, do this. So we have to compare the values currently stored in number and lowest. So 563 is indeed less than 900. So we are going to execute what's inside this then clause. So the value in number will be stored in the variable lowest. So basically this value will overwrite what's currently stored in this value. So I'm just going to copy it across. And then we can just ignore the else statement because the if was already met. Okay, so now we are back to line 3. So we incremented count by 1. So we input number again. So in this case, it is 21. And then we do this if check again. We compare if number is less than lowest. Yeah, so 21 is indeed less than 563. So we execute the then clause, which overwrites lowest with number. So I'll just copy that across. As you can see, we always compare the latest value of each variable. In this case, it was 21 and 563. So once we write a new value in a new row, we ignore what was written as the previous value. So that's why we compare 21 and 563 because these are the latest values stored inside of these variables. So I will just write 21 here. And then we ignore the else clause and we go to the next iteration. So I will increment count and then input the next number, which is 376. Okay, so then for the if, so in this case, 376 is not less than 21. It is actually greater than 21. So instead of doing this then clause, we'll just do this else clause because this is not true. So we go to here. So if number, which is 376, is greater than highest, which is 1, then we overwrite highest with the value that's stored inside number. We just overwrite the value. So instead of being 1, it is now 376. So it's okay to leave these blank. If you leave it blank, it's like saying like this value did not change throughout this time. You're saying that, oh, it's just the same until it changed. But if you wanted to, you could also write like ones inside here. But it's also okay if you don't. So both ways are okay. Okay, so that ends this if statement, and then we go to the next iteration, count increments, and then a new number is inputted. 99 is not less than 21. So we have to go to the else. So here, 99 is not greater than 376. So this if is also not fulfilled. So we basically just ignore it and then we just end the if statement. So basically, these three values did not meet any of these if statements. So we just like skip the entire if. Then we go to the next for loop iteration. So count is 5, and the next number that's inputted is 400. And then 400 is not less than 21. So we go here, but 400 is greater than 376. So we store 400 into where highest is. And then yeah, so now our for loop has ended because we've already reached 5. So the whole for loop ends. And basically that's the end of the program because we have no more lines to follow. So this is our final trace table. And then this is the mark scheme for this question. So basically in the mark scheme, they did write like every number into every row to always keep showing what is the current number. Again, it is also okay if you don't want to, like if you just want to leave it blank, because it just has the meaning of saying, oh, this number stayed the same until it changed. And then this number stayed the same until it changed. So it's just saying, oh, it just carries across. But you can also write it into every row. So if you want to write it into every row, something to be careful of is that you don't accidentally write, like you don't accidentally copy the wrong number. So this is 21. So it's also supposed to write 21 here, right? So don't accidentally write like 12 or like 20. And then for this one, if you want to leave it blank, you should make sure that you correctly, like, since there's blanks, right, you shouldn't accidentally write it into the wrong blank. So for example, this one is 400. So don't accidentally like write it in the wrong row when you're like copying across. Make sure that you always write it in the correct space because all the blanks can be a bit, because for some people the blanks might like confuse them. Whereas if you write it out like you always make sure every row is filled, like there's a lower chance that you accidentally write something in the wrong space. Okay, and so now we're going to go do question B. So question B says the algorithm does not work correctly. State the reason why the algorithm does not work as expected and explain how the algorithm could be corrected. Any code used must be fully explained. Okay, so the question says that the objective of the program is to store the highest number and the lowest number entered. So in here, we see that from these inputs, the correct output should be that 21 is the lowest number and 563 is the highest number, right? Based on these 5 inputs. But then if you see here, the lowest number is 21, which is correct. But then the highest number that we got is 400, even though it should be 563. So it means that the program stored the highest value incorrectly. So in here, we can say that the final highest score is incorrect. And then as for the correction, so how did this happen? Basically, we started off with 1, and then the first input is 563. So this should be stored here and then not updated, right? Should just be put here. But then instead, what happens is that it got stored into lowest. So if we go through this line by line, okay, so first we stored 900, and then we stored 1, then we inputted 563. So this is correct so far. But then in this if statement, we compared number with lowest. So at that time, lowest was 900, and we had just inputted 563. So of course, this 563 is less than 900. So it ended up getting written to lowest instead of highest. And then because this if was fulfilled, we just ended up skipping this whole else statement and then going to the next round of the for loop. So this is an issue with the first if checks, where basically for the first input that the user gives, it checks if the user's input is less than lowest, but it doesn't check if it's greater than highest. We should check if it's less than lowest and also if it's greater than highest. Because in this case, 563, it is indeed less than 900, and it also so happens that it's also greater than 1. So actually, however, the program did not recognize that because we skipped over this whole if statement. So one solution for this would be to take out this whole if and then make it its own standalone if statement rather than nesting it inside of this main if statement, we like take it out. So that we have an if check for if number is less than lowest, and then we do this. And then we have a separate if. So if number is greater than highest, and then we do this. So we just have like two separate if statements. So that is the correction. So I'm going to write that the else clause on line 8 can be removed. And also, instead of having a nested if statement, two single if statements can be used. One for checking number is less than lowest, and one for checking number is greater than highest. And then this is what the mark scheme says. So yeah, highest score is incorrect. And then we remove the nested if and have single if statements for highest and lowest. Okay, so I have another question that I want us to look at. This question says, this flowchart represents an algorithm. And then we have a flowchart. Then complete the trace table for the input data. And then they gave us lots of values. So first we have to read the flowchart because they didn't give us some context behind it. So we need to understand the objective first. So we have the start terminator, and then the word continue is outputted, to which the user has to input their answer, and then their answer is evaluated. So is answer equal to y? So if it's not, then the program ends. But if it is, then the user has to input value 1, input an operator, input value 2, and then their operator is checked. So if the operator is A, then the values are added and the final result is outputted. If it's S, then the same thing happens, but the values are subtracted. If it's M, then they are multiplied and the values outputted. And if it's none of these, then it's just assumed to be divide. So okay, so at the end of all of these branches, it goes back to the beginning and the whole process will repeat. So the program will end when answer is not y. Okay, now that we have a better understanding of what is happening, we can fill in the trace table. So starting from the top, the word continue is outputted. So I will just write that in. And then answer is inputted. So the first value we're given here is y. So I'm going to put that into the table. So I'm going to put y on its own row. And I'll explain why. I'll explain why in a bit. Okay, next we check is answer y. So yes, it is. So we go here, the input value 1, which is 7. And then input the operator, which is S. And we input value 2, which is 9. So we are dealing with a lot of values. So what you can do in the exam is that once you've inputted some values, you can use a pencil and then like cross it off like this. So it's like to prevent you from getting confused. Okay, and then now we check is, okay, so we see operator is S. So is operator A? No, it's not. So is operator S? Okay, yes. So we output value 1 minus value 2, which in this case, value 1 is 7, value 2 is 9, so 7 minus 9 is negative 2. So then this goes back up here, and we go back to the beginning. Now that we're back at the beginning, we go here, so output continue, and then we input answer, which is y. So again, I'm going to write it on the next row. And then I will input value 1, operator value 2. So this is 5, m, and 12. So now we check is operator A, is operator S, is operator M. So now we go here, output value 1 times value 2. So 5 times 12 is 60. Okay, so do you see how we are separating all of the rows? Like we have continue on its own line, and then we have these values all grouped together, like on their own rows. In the previous question that we did, we grouped the values based on the for loop iterations. So in every new iteration, we always go to a new row. So when in count equals to 1, we use this row. When count equals to 2, we go to a new row. When count equals to 3, we go to a new row. So we always split the rows by the counts to show that, oh, when count was equal to 2, these were the values. When count was equal to 3, these were the values, and so on and so forth. So it shows like how the values were grouped and when. So for this one, the reason why I decided to put these values on their own row is because I wanted to show that these came after continue. So continue came first, and only then it was these values. And then here continue came again, right? And only then these were the values. Yeah, okay. So it would look like this if I didn't skip a row. So you see it becomes less clear on the order of the outputs. So like technically this is like, well, it's not really wrong. It's just that it's a bit less clear compared to the previous one. Basically, knowing how to group the rows in the trace table is something that you need to practice. It's something you need to do past papers to know, like, to better understand how to group together the results. But in the exam, don't worry too much about like the whole row and spacing thing. Even if it's like a bit different from what the examiner was expecting, it needs to at least make sense. But of course, all of the individual values will need to be correct. Because if it still logically makes sense, then they will understand. But if it's obviously wrong, like it's obvious that your variables didn't follow the correct order, then you will lose the marks. Okay, so let's continue. Okay, so we go here, output continue. Okay, and then input answer. Okay, so I already used up the last four. So now it is Y. Value 1 is 25. Operator is D. Value 2 is 5. And then here, operator is not A, S, or M. So we output value 1 divided by value 2. So 25 divided by 5 is 5. So we're going to put it here. Okay, now back to the beginning. We output continue. And then input answer, which is N. So I'm going to put it on the next row. Okay. And then is answer Y? No, it is not. So we stop the program. We've used up N, but there's still three values, right? But since the program has already ended, we're not going to need them. So it's perfectly fine to just ignore them. Okay, and so now let's look at the mark scheme. Okay, so yeah, so ours is the same as the mark scheme. So yeah, that's it for this video. I hope that it has given you a better understanding of why we use trace tables and how to go about doing trace table questions. So yeah, that's it for this video, and thank you so much for watching.